All right, everyone. I think we should be live now. I'm gonna wait for some time and then it will be live. I'm gonna let it zoom in thoda. Think we should be live. Yeah, perfect. Okay, we are live. Congratulations. And we have a few things to learn today. One of the thing that I was very interested personally was about congratulations. Okay, and oh shit, there must be some echo. I'm sorry. I'm sorry. I'm sorry. Okay. All right. I'm gonna start recording as well in the like once I start. So don't worry, guys. You will feel a better version will be available after this is done. Okay. Today we have a lot to learn. So let's just go through this and pop out chat. Bring it here. As soon as people start joining, they can come and say hi, and that is it. Okay. Um. Yep. One thing I want to do is this US. Wait a minute, guys. I need to find out. So there was UX Play, right? That you could use, and I'm not sure how does it work. But let me check if there's an AUR for this. Yeah, there you go. I think I can guess. I mean, I guess I can use it. So let me just do this. UX Play. Also, let me do this for the sake of get later on. Yeah, okay. You are here. Sorry. Let's build the package. All right, so once this is done, what we'll be able to do is we'll be able to share our iPad screen and then I'll be able to talk through about some important things. Otherwise, like, of course, hope you guys can see my screen. Hope you guys can come over, say hi in the chat. Let me just make sure that I'm not missing out on anything. Yeah, I don't think I am. Whenever you're here, all you have to do is probably just click on this and they should work. So that is one step that you guys should follow. All right, I'm gonna wait. I'm gonna wait. Once this is done, we'll go forward. What happened to this? It's installing some GST plugins. This is weird. So I understand there's like some GST plugins. By the way, did this happen? Ah, yes, nice. Oh, this is going live, right? Oh, wait. I think this is going live. Who is taking more number of wickets? Akashdeep is at 1. Raminda Jadeja is also bowling. Oh, Sam Constas is at 101. Okay, not bad. Who took a lot of wickets? Harshit Rana. Yeah, of course. He's just 19 years, man. Look at him bowling. Oh, so this is a 46 hours game, is it? 2-day warm-up match. Oh, so this is like okay. Why is this not working? GST plugins good and bad. What's wrong? Do you need me to do an update? Yeah, it could be this. Okay. Some reason the internet is slow. I think I know why. This could be because of this. So let me go. Oh, this is done right, so it should be fine. Yeah, I have no idea why the internet is so slow today. Yeah, there you go. Huge update. I'm gonna let it happen. All right. Okay. All right, guys. So the motivation for today's stream slash video was to understand how does PyPy work and what is really PyPy, right? What is PyPy really, and can you explain me this thing? Okay. So I asked this question to ChatGPT because we all know that there are many implementations of Python interpreter out there, and many would claim that they are faster. Like for example, there's Jython. If you search, so Jython is there. Python for Java platform. There's, um, I mean, I think there is this PyPy and there's CPython. but I'm not sure if they are the same because this why is it so slow? I'm not sure, but this yeah. So this is the implementation of Python in Java, right? So only version 2.7 of Python can be supported at present. They're still making things, changing things. I don't know, right? So it's very important to understand what is PyPy because it's one of probably after CPython one of the most popularly used. So let's go to GitHub PyPy. You will understand there. So CPython is a reference implementation of Python. It interprets Python code line by line. And PyPy, what does it do? It uses JIT compiler to optimize and speed up code execution. So what is JIT really, right? So just in time compilation. Let me just okay, it's still going on. So what does it do, right? So let's say when you're trying to compile the code, right? In Python, you don't really compile the code. So at runtime instead of at compile time, what it does is it tries to find the hotspots. And by hotspots, you mean that whatever positions in the code that are taking longer than usual, and you will try to just in time compile them to native machine code which can be run directly, right, along with the execution. So what that means is, let's say you have a CPU version, you support this instruction set, depending on the CPU, depending on the kind of CPU, what is support, there are things that you could use. So based on that, it just decides, okay, hey, this is a for loop that's going on and that could be optimized. And so this converts it into a machine native code, and then you can directly execute this, right? So as you can see, Python's JIT compiler analyzes the code while it's running. So while it's running, JIT compiler will also analyze the code, right? That means that there's some overhead about it. So not necessarily that even for small for loops it will be faster. So just understand that it comes with a cost. It identifies hotspots, frequently executed portions of the code, right? So I mean, honestly, there are multiple definitions of hotspots possible. Over here, they've mentioned that frequently executed portions of code, and that's why they've said for loop because because if you're iterating through an array multiple times, let's say the array length is 1 million, right? So you'll be iterating through it. So the addition operation, whatever operation you're doing on each element of the array, that is frequently executed, right? So that kind of could be termed as a hotspot as well. Now, these hotspots are converted into machine code that CPU can execute directly, bypassing the need for interpretation, right? Because see, whatever Python language, if it's not compiling it, it interprets into some IR code and all, and then it's run basically into machine code or something, right? So what it does, it kind of skips the interpretation part and just directly converts it into a machine code, right? So PyPy implementation is inefficient garbage collector. It's a very interesting garbage collection. What they may probably call it as generational based garbage collection. I'm still waiting for this to finish. This is very slow, and I'm really sorry. I don't know what's happening though. Guys, oh, I think then let me just confirm. It should be live now. Yeah, it's live. Okay, sorry. So just to fix that, I kind of disconnected and reconnected. Anyways, so this should be fast now. Yeah, very fast. Cool. Good. All right. So what does it mean, right? So generational base basically means that there are two type of generations it divides the code into, right? One is young generation, the other is old generation, right? And so young generation, by that it means that whatever that is short lived, right? Some objects are very short lived. If you look at the code, you understand that okay, when you define x equal to 3, it's only used once when you do an addition, and then after that it's not lived anymore. So that's something that you can call as a young generation. And an old generation is something that you can use and it's probably lasting longer. It's also used towards the end of the code and all, right? So end of the whole timeline, you could say anything like that. So I mean, that kind of garbage collection they have defined, and we'll go through that in detail because I wanted to understand this more. If you guys are not aware, we do have a blog on it, and it was something that, like on garbage collection, we have gone through free lists data structure, but like let's move forward and try to understand the other one, right? So PyPy removes many of the inefficiencies of CPython. For example, it avoids some overheads related to dynamic typing by optimizing the type of variables during runtime. I'm not sure about that, to be honest, but my main focus was to understand, okay, how does the garbage collection work, right? Okay, it's almost there. Hold on. So PyPy programs often run 2 to 5x faster, long running or compute heavy tasks. Of course, much faster for them because of JIT. Uses advanced memory management techniques, compatibility limitations. So as we understood, like startups time, because JIT compilation will do some analyzing of the whole code and then it will try to optimize. So this takes some time, right? So just understand that in the runtime you'll have some addition of performance. during the startup. And C extensions, some Python libraries written in C, those use Python or relying on CPython specific APIs may not work seamlessly with PyPy, though this has improved significantly over time. So this is more like a compatibility thing because CPython specific APIs will not be supported in whatever Python libraries that you're writing in C. Now, PyPy's executable is larger than CPython's because of JIT compiler and the features. Like, understand, guys, when you try to um, create an executable out of it, right? Which you will generally not, given that it's an interpreter. Like Python is an interpreted language, right? It's not a compiled language. But what it means is when you're trying to generate the runtime, JIT runs initially and tries to analyze and optimize the code. Then it internally has a machine code as well, right? So that does increase the memory because you're storing some extra part of code as a machine native code, right? So I mean, so that's what it just means, that it's larger in size. Um, you can install PyPy, you can run things. That's totally fine. Not really gonna go through that. I think for now this is something that you've mentioned, right? This is JIT compiled. So probably you might have an executable from here, but I'm not sure. We'll have to see. Fast, complete, improving, whatever. Damn, this is the thing that I wanted to talk about, right? So custom garbage collection system that differs significantly from CPython's reference counting mechanism. So what they do is basically they trace the live objects, right? So they understand that okay, this object is going until this point and all, and they don't use a reference count mechanism, which is basically used by CPython. If you guys know a bit about CPython APIs, that you will see that you use this thing which basically allows you to print the def count of an object in C API for coming from CPython, right? So I mean that's how it's used. So PyPy uses a generational garbage collector, which basically what I informed you guys about was young generation and old generation, right? So young generation is basically newly created objects. Garbage collection occurs frequently here. Old generation objects that have survived multiple garbage collection cycles, collection is less frequent here. That means that okay, your GC gets run, but you that object still survive. That means that okay, it was not garbage collected. That was somewhere used, right? So I mean, those things are that's how they divide it into two generations. And as I said, like they trace live objects. Those are that are reachable from rows such as variables and stacks by traversing object references. Okay, that I did not know that they only do it for the uh, such as variables and stacks only. Okay, any objects that are not reachable are considered garbage and deallocated, right? So tracing GC is better than ref counting, of course, because you don't have ref counting override. You don't have to keep a track of ref count of each object as it goes along. So CPython uses ref counting, which means every object has a reference count that is incremented or decremented wherever references are created or destroyed. This can lead to significant overhead. Yeah, I understand. Right? PyPy avoids this overhead entirely by using tracing. Yeah. So C, A points to B, B points to C, C points to A again can cause memory leaks because ref counting cannot resolve them. Tracing will help do that. Okay. Incremental and parallel collection. What does it mean? So PyPy performs garbage collection incrementally to avoid long pauses. Okay. Instead of stopping the entire program for a full GC cycle, it breaks the work into smaller chunks and interleaves them with program execution. So this reduces latency and ensures smoother performance in real-time interactive applications. I see. Okay, so they don't do this that okay for the whole entire cycle I'm gonna run GC only once. It does incrementally. In some cases, PyPy can use this multiple thread for garbage collection, taking advantage of modern multi-core processors to speed up the process. Okay, understandable. Write barriers in card tables. Whenever a reference to an old object is modified, adding a reference to young object, the garbage collector is notified to ensure that the young object is traced correctly. Right. So there's a lot of communication that would go on between the object and GC, right? Because you would want them to know that okay, there's one ownership that has been transferred or anything else, right? So when you are adding a reference as well, when you say x equal to a, now x also has a reference to a, right? So that needs to be informed to the GC. Memory is divided into small cards and updates are tracked at the card level rather than individual objects. Okay. I am not sure about this, but yeah. Anyways, I think this does give us some idea about how does the GC work differently. All right, guys. I think for now I'm gonna log off. Not enough people on stream, so I'll probably go and take a break. Maybe next time. Thank you so much, guys. Everyone. Bye bye.